Hi, everyone. Thanks for joining us. My name is Leo Chen. I'm here to talk to you today with Michael Hyde. I am the worldwide tech lead for spatial computing at AWS. We're talking about augmented reality product previews using only web browsers. Michael, would you want to introduce yourself?
Hi, everyone. Michael Hyde here. I'm a senior solutions architect, and I enjoy working with this augmented reality and helping to show you today how to convert models from one format to another.
I'm super excited to present this material today because AR, of course, has the potential to really change the world for online retailers in many ways. We'll get into in a minute, but up until recent advances in web browsers, this is being recorded live, of course, at the end of 2020, you had to do a lot of specialized programming, develop apps or custom apps to enable AR for your customers. Now you can release AR product previews only using web browsers with just a couple lines of HTML code. You don't need custom developers. You don't really even need to understand a lot about how simultaneous localization and mapping works. You can just use it as you would any web element. And we're going to show you how to do that today. It's really just a matter of getting your 3D model files for your virtual objects in the right format and then publishing it on the web in a way that you can see it through S3 or CloudFront. So we're getting ahead of ourselves, but we'll show you all that coming up here. Now this webinar is going to walk you through a technical implementation guide that Michael and I wrote by the same title, Web-Based Augmented Reality for Retail Previews. If you look in the live chat window, here's the URL for the paper, so you can download it and follow along. And if you're not watching live, please look below for the URL to this paper so you can follow along. It contains written step-by-step instructions to show you how to do everything that we're going to show you today. So without further ado, let's jump into it. So let's start out with the why augmented reality or AR previews are important for online retailers. Traditionally, we know that online retail traditionally asks customers to evaluate a product, such as this chair in this example, using marketing images or reference images to imagine what the product would look like in their space. And that's not bad, but this can lead to returns, this can lead to disappointment, it can lead to buying things that are the wrong size that don't fit into your environment because you might not know the exact dimensions. AR, on the other hand, allows you to take a virtual version of that product and place it in your environment on your mobile phone and evaluate it in place. That allows you to look at the color scheme, the size, and the fit to make sure that it fits just the way you want it. So for this example, if I show the video here on the right, you'll see the chair actually is shown in my office here on the right. It is shown with this leather ottoman, that's a real ottoman, and you can see it doesn't quite match, so color-wise, so maybe I would make a different choice, maybe choose a brown chair or a different chair altogether. But importantly, it also shows me the size and the height of the chair, so I can evaluate how it's going to line up with this ottoman and whether or not it fits in with the color scheme of my room. Ultimately, for your customers, this leads to increasing customer engagement with the product itself. So rather than looking at example photos, they can pull that product right into their space, move it around, evaluate it, share it with their friends, families, and spouses who are in the room to get shared opinions of it, really increasing the engagement with that product, which can lead to higher conversion rates and greater engagement with your website. It also gives them a more accurate evaluation of the piece in their space, which then ultimately leads to fewer returns because they don't have to actually ship the object to see if it fits for size and for color matches. These are all bottom line attributes that our customers tell us are important to their business. But when it comes to the customer experience of getting that downloaded augmented reality experience, there's a few things that our customers are also telling us that they want. First is they want a very low friction experience for their customers to do the AR preview. And many customers do not want their customers to have to download yet another app. There's a real app fatigue that's happening on mobile phones that our customers are sharing with us. So Wouldn't it be great if you could just get an AR preview that runs in your native mobile web browser on your phone? You wouldn't have to download any apps. That also means you can share the experience by simply sharing a URL, which means you can send a QR code or a link in an email or in a chat or in a tweet, and people can follow it directly without having to download anything. And the thing is, it has to be accessible. And what I mean by that is that you want it to be able to work across a large number of mobile devices, from iOS devices to Android devices to iPads, tablets, phones, any modern phone. And the good news is that the experience we'll be showing you today works on basically any modern phone, within the last 2 years, so 2018, 2017 onwards. Depending on the grade of your phone, an older phone might even work, but both for iOS and Android. Because it uses the web browsers, you don't have to worry about the hardware or the target platform that your customer is using. The web browser, like all web browsers do, provides you an abstracted platform. So you can publish once, like you would a web page, and it just kind of works on all these different platforms. So there are over 1.3 billion AR-capable mobile devices at the time of this recording out there. By 2022, the prediction is there'll be over 3 billion AR-capable mobile devices. So you can see that it's a large surface area for you to access for your customers. So with that, hopefully that motivates the why we are doing this and gets you motivated about why you would want to incorporate AR Preview into your online retail site. And I'm going to hand the mic over to Michael and the screen control as well, so that Michael can bring you through what you need to do to prepare your files to be ready for AR Preview. Michael?
Thanks, Leo. Michael here, and I will be walking you guys through the architecture of this solution. So you can see on my screen here, I've shared an architecture. This is also highlighted in that document that Leo talked about. The link is down below. And in this architecture, we have on the left-hand side, you uploading your 3D model. You upload that into an S3 bucket, and it gets stored in this bucket. And then when you upload the file, it triggers an S3 event, which in turn triggers a Lambda function. And then this Lambda function will start up a container. So a container is kind of a self-encapsulated package of software, and the container that we have for you is to convert the models. So there's lots of different formats of these 3D models, and you need certain formats and certain perspectives for displaying them on your web page. So this container will convert from a GLB format to a usdz format. There's more details in this document, which you can read through. And then after it does the conversion, it will put it back up in this bucket and then make it available for your website. So this kind of is fairly simple here, but it can still take a bit of time for you to go through and spin up all the resources and configure it. So to make your lives a bit simpler to explore this concept, we have created what we call a CloudFormation template. This template is a series of instructions that are run by AWS, and it will provision all of those resources for you. And now I've shared the article here, which we've referenced before here. And I'm just going to scroll down in this until I find the details for this CloudFormation template. So we've provided this CloudFormation template, which gives instructions to AWS to provision all those resources in the architecture document. So as I'm scrolling down, you'll see the architecture document, and you can go back and reread this and kind of digest it at your own leisure. Coming down, we have this link here. It's just simple. You click on the link, and then that will bring you to the AWS console. If you haven't logged in before, it'll come up with a login prompt. So put in your credentials, and then it will take you to this quick start for this stack. You can see at the top, it's referencing a file. You put in your name for the stack. In this case, I'm going to put in AR-model. And then there's just some parameters here, which are required for networking. Down at the bottom, you need to acknowledge and click the button for Create Stack. So you can see this goes off and starts running. This takes about 5 to 10 minutes to provision all the resources. And just as it's provisioning, I'll talk you through some of the aspects here. So you can see a number of these events that are going through. So this just kind of goes through and lets you know as it's creating the various aspects. You don't need to worry too much about the details. You just need to keep on going until you see at the very end, you'll see this saying AR model, and then the status will be done. If you want to see what's going on, you can just kind of hit refresh here. And now that it's provisioning here, I'm going to start to show you some of those other services. So I will open up another window here and look at S3. If you recall, the starting of this workflow is in S3, and in S3 is where we create this bucket. Now I've brought up the console here for showing S3, and S3 is our object storage. So this allows you to take objects, which are files, videos, or in our case, 3D models, and store them in the cloud at very low cost. And so at the core of this is what we call an S3 bucket, which is just, you can think of this as a file system where you upload your files. And you can see we've created three folders for you, a GLB, HTML, and usdz. So the GLB is where you upload your incoming files, and then that will trigger the Lambda and the conversion process. And finally, all the files will be put into this usdz folder. The HTML folder is where we've uploaded a sample HTML file just to show you how you can integrate this into your website. So now that we have this up here, we have this folder, I'm going to show you where this S3 event. So I flip over to properties, and if I scroll down, we can look at these S3 events. And so this is all created automatically by that CloudFormation template. And if I go in here, I can click edit and show you what has been created. So this S3 event is triggered on any object that you upload. You upload it into the GLB folder, and it has the suffix of GLB. So every time that you upload a GLB file, it's going to create an event and trigger a Lambda function. So now that we've looked at this S3, I'm going to go up to the services, and we will go look at Lambda. I type into the anywhere bar, and it shows me the option here. And now this will take us to the Lambda console. And you can see here is the Lambda function for converting. We can click on that. Now this will bring up the Lambda function. A Lambda function is a way for you to run like event-driven code. In this case, we've chosen Python for our coding language. And the good thing about Lambda and the ECS that I will be showing you shortly in the containers is it's all serverless. Because it's serverless, you don't have to worry about provisioning or managing any of the underlying infrastructure. That's all handled by AWS. This kind of allows you to focus on the creative process of creating these models, updating the models, making them available to your end customers. So with this Lambda function, you can see there's a S3 here. This means that it's a trigger. So this is just another visual representation that when you upload the file, it will trigger the Lambda function. And then I'll scroll down here a bit more, and this is where the Lambda code is. This is kind of where the magic is. So you can see, I'll just go down to the bottom here. So taking a look down here at the code, when you upload the file into S3, a number of parameters are passed by S3 into the Lambda function. Most notably, it passes in the bucket, so that's the bucket name, and the key, that's the name of the file. And because this is all self-managed by AWS, you don't have to worry about scaling out the solution. If you upload one file, it will start this Lambda function and start it going. If you upload 5 files at the same time, each time you upload the file, it will trigger an independent copy of the Lambda and start the conversion for each of the model files independently. So this allows you to upload 5, 10, 50 files or files of these models, and then it will scale it out automatically to handle that and process them all in parallel. And what it does is it takes those incoming files, its location, it computes an outgoing location, and then passes them into the container. You know, I've talked a bit about this container and how it is this encapsulated code for doing the conversions, but you need some parameters. Because you can run this in parallel, you need to know which is the source file and what is the destination file. And we pass this in here. You can see this little name called overrides, and we pass them in here as various parameters or environment variables. So now I've talked pretty much about Lambda. We will switch over to ECS, which is our Elastic Container Service. And this is our framework for running containers. Our container is based on Docker. We've made this all available for you. It's deployed and provisioned and set up as part of this CloudFormation template. At the heart of ECS, the Elastic Container Service, is what we call a cluster. So I'll click on the cluster here. And this contains all of the code for running the containers. It is running on what we call Fargate. This is our managed service, which will provision all the infrastructure required to run the containers here. So we can see that we have this service. We can look over and see the container. We also call this a task. And we can see at the top part here, excuse me, you can see at the top part here, the permissions that we've set up for it. You can see that we're setting it up to run with Fargate so that we will manage all the infrastructure. AWS will manage all the infrastructure. If I scroll down, we can look at some of the parameters. I've set this up for just minimal parameters right now, 512 memory and the CPU. And we found that this works quite well for these model files. If you find the conversion process is taking too long, you can go in and tweak these settings, allocate more resources, and it will process quicker. I'll scroll down a bit further here, and this is some of the container definitions. So of note in here really is these environment variables. So these are parameters that are passed into the container and control how it runs. We set a default region here, which is just in our North Virginia region, and these are default values that are overridden by the Lambda function. So every time that you upload the file, we pull out the parameters of its location, its file name, pass it into the container for it to run. And then after it runs, it will output the files and put it into back into the S3 bucket. So that's covered all the resources here. So I'll just flip back here quickly to the PowerPoint and just to summarize what we've gone through. So we've gone through and we've created this S3 bucket, which was where you upload the original model files. We have a Lambda function, which is triggered every time you upload the file, which will start our container, which will do our conversion, and then the converted models are put back into the S3 bucket. So now I'm going to go run through. I'll flip back here to the console and go over to the S3 bucket. And there's a history here, which I'll click on. And here is the bucket, and I will upload one of these models. In this article that we are going through for you, we have a link to a 3D model of a Pergolesi chair that's being digitized by the Smithsonian Institute. So this is a chair that was created in the 1700s, and it's been digitized, and this will be used throughout the remainder of this presentation. So we'll go into here. I will go and click on Upload and Add Files. You can see here that I have uploaded, that I've two models here, two files, a LAMP file and this Pergolesi file. So when you're running through this, you just make sure you keep this same name because all of our examples kind of rely on you using this format here. So I'll hit Open and Upload, and at the bottom you'll see the progress bar here as the file is uploaded. As the upload completes here, it's in here. This will now trigger that Lambda function, and the Lambda function will in turn trigger the container and ECS. So I'll flip over back to the container service, and diving into the cluster, we can look here at the series of tasks. So this task, you can see right now, the status is provisioning. So when it's provisioning, this means that it is creating the underlying virtual machines that will run the container. It's downloading the image from the repository. It's creating all the networking, all the security that is required to run it, which is fantastic because you don't need to worry about that aspects. It just kind of happens and it is reliable. So if you want to see what's going on, you can click here on the task name. And this is just going to go through the various states. Right now it's in pending. It takes a couple of minutes to provision all these services. And I was going to say, is there anything else here in particular? We just wait here for the resources. And now you can see when I hit refresh that it's gone from pending state to running state. that means the container has been loaded. It is actually starting to run through its code for conversion. And you go, hey, that's great, but it would be nice to know what actually is going on. So to see a bit of insight into what's going on, we can flip over to the logs. There's a nice tab up here. And I'll hit refresh. If there's nothing there, just hit refresh. And you can see it's run through all the steps. You can see at the bottom is the first step. So it's copying it from the S3 bucket. It's now completed. It then starts converting it from one format to another. And when it finishes, it uploads it back to the S3 bucket. And you can see it's a fairly straightforward process here. And what I find kind of even more impressive is the timing. If you look here at the timestamps, it started at 39 seconds and finished at 45. So it only took like 6 seconds to do this full download, convert, and upload back to S3. So you can see if you have to convert a large number of files, it is relatively quick. And because it's all serverless, you don't really have to worry about any of the underlying infrastructure. You can just worry about the models and presenting them to your customers in a way that helps them understand your products and hopefully buy them. Now I've finished going through the architecture here, and I will hand it back to Leo, who will show you how to actually present this and have your customers view this on your websites. Over to you, Leo.
Thanks, Michael. So I have your architecture diagram pulled up here again. And just for context, the reason why we do this backend process of converting from GLB file format to usdz file format is to support both Android and iOS platforms, as I mentioned before. The state of the web browser standards right now is Android expects a GLB format and iOS expects a usdz format. So we need them in both. And as Michael has shown, we have provided this serverless way to easily convert from GLB to usdz at scale. So moving forward to the front end of how to present the usdz or GLB file in your web browser, I'm going to take you through a web page tour of the sample HTML that we provide in the article. Let me just switch to my web browser here. And this is a rendering of what you will see when you bring up that sample .html file from, you can get to this from the CloudFormation Outputs tab. You'll see a URL that goes to your CloudFront distribution of your S3 bucket that has the HTML, the GLB, and the usdz file. So what we can see here is that Pergolesi chair that Michael converted is right here. Just find my mouse here because it doesn't seem to be coming up. There we go. So you get a 3D view of it. So I can tumble it and I can view it. And this is happening on a web page, of course, in 2D, 3D, but on a 2D page. And then what will be more exciting is when we show you this, how this, well, the same model can be viewed in AR on your phone. This web page is meant to represent, of course, just an example of how you might present the model in your own online retail store. It's not particularly pretty, but it gets the model components across here. So I'm going to just go ahead and open up the Web Dev Console to jump into the components out here to show you how this is done. So the thing that we're all interested in, of course, is this model component right here that actually represents the chair. The rest are just images and text, of course. So the heart of this is a model viewer web component that's available through open source. And you see that it's basically all it sets some parameters to allow it to rotate automatically, which is lets it spin around and allows me to provide camera controls to allow me to move it. But the heart of this is this SRC attribute, which points to this CloudFront location of the Pergolesi chair that Michael has uploaded and converted onto S3 and CloudFront. And that is what pulls in dynamically the 3D model and allows me to see it in this web page here. The other thing that happens is this tap to view in your space button. So if I go and look at the element for that, you'll see that there is, it says that when you click on it, it will bring up a QR code. So it brings up a QR code if and only if I'm on a laptop, if I'm not on a mobile device, as I am now. I'll show you the actual source code that does that. So there's this if statement here, this branching statement that says if I'm on a desktop, show the QR code. If I'm on an Android, use Model Viewer to show the AR using the GLB file. And if I'm on an iOS device, use the usdz file and quick look to view the file. And we'll show you all three of these examples in just a second. Now I'm on a desktop, so when I click on this, what happens is this QR code comes up. And the QR code is a URL to the same page that I'm looking at here. So it just points to itself. And the idea here is you're directing your customers to view the exact same page, but on a mobile device, because you can't view AR on a desktop. So the idea is you point your mobile device directly at this QR code and it'll come up. And by the way, this is live. So as you're watching this, if you point your phones to your screens, you can get this chair in your own environment as you watch. So I have a pre-recorded video here of what that looks like on my phone. So I'm just going to switch over to that. So I'll show you first what that looks like on my Android phone. This is a Pixel 2 phone. I'll just play this forward here. So I point it at the QR code and I get a link there you see to an HTML page. Now it's opening up Chrome on my Pixel phone. This is not an app. This is running in native Chrome. I see the exact same web page, and when I tap to view in your space, it brings up the AR viewer, which allows me to bring that chair, the same GLB file, inside my living room, my office here, and you can see it changing lighting to the environment. There's some contact shadows beneath it. It shows me exactly how big this chair is. Because it's from the 1700s, the chairs were a little smaller back then, but you can see a lot of the great detailing and how this would integrate into my space. And you can see that for my particular office, I should probably buy a chair like this rather than that gray lounge chair that I was looking at from Amazon.com. I'll show you the same file or the same web page, but through iOS this time. So this is on an iPad Pro. It's probably circa 2018, this iPad Pro. Into my desk again. So if oh look, I had lunch there on the right. So if I press play here, I go back up to the QR code. This time it opens Safari. The same web page comes up in Safari. If I click on tap to view in your space in Safari, it brings up quick look in iOS. You can see the UI is just a little bit different. And it brings the same chair up, this time through iOS. Slightly different look and feel, but still very convincing and great for evaluation of the product within my own office. So with that, I'll go back to our presentation. And I encourage you to try this, of course, at home in your own space. Let's go through some frequently asked questions about this particular demo. So the first question we often get from customers is, where can I get the 3D models? This all started out with the Pergolesi chair and assuming that you could get GLB files or any 3D model of your products. There are, if you're just starting out and you want to run a quick proof of concept or experiment, there are online freelance 3D artists, mainly from the visual effects and gaming community, who can freelance and build objects in your product catalog based on photos. So you can take a series of well-lit photos from different angles of your products and have a freelancer build them for you to just get your proof of concept working. GLB is a common output format, so they can deliver you those files in GLB, and then you can run with the tutorial from there. If you wanted to do this at scale and, of course, model an entire catalog, you could look at either hiring a team of modelers, contracting it out to a vendor that does modeling for you, or you can look into more automated approaches using photogrammetry, which is a technology that builds 3D shapes from photographs, depending on the quality bar that you're looking for and how much control you want on the actual model. The second question we get often is, do models on S3 need to be public? The answer is no, they do not. In fact, we encourage you not to make them public for security reasons. The HTML file and the S3 access to the GLB and usdz files is provided through CloudFront, our content distribution network. And CloudFront, this was all set up through the CloudFormation template that Michael took you through in the beginning. That sets up permission and authorization for your application from CloudFront to pull those files, the HTML files and the model files from S3. So they remain private and are only accessible through that CloudFront endpoint. And that is a more secure way to distribute your content and to make sure everything is only gets distributed to that CloudFront endpoint as intended. I'll hand it over to Michael to go through our last two frequently asked questions here. Michael?
Yeah, so the next one is, what are the AWS costs? And because this is all running as serverless resources, it is quite cost effective. We did a calculation for this Pergolesi chair, and for you to run one conversion of this model, it works out to be about 1.5 cents for the storage in S3, the Lambda function running, the containers provisioning, and the hosting through CloudFront. It works out to be about 1.5 cents for that. And we took that and it should scale fairly linearly after that. And so because it's all serverless, it's all very cost effective, and you're only paying for the resources when you're using them. It's not like you have servers that are sitting there idle and paying for them. It's only, you only pay for when you're actually running your model pipeline here. So let's move on to the next one here, is how do you clean up the AWS resources that are created? So that is the magic of this CloudFormation template, is you can go through, and when you're finished going through like this little demo and seeing how it all works in your office, you can use the CloudFormation template to clean up all the resources. So I'll take control of the screen and just walk you through that process. Now I've switched over to the AWS console, and you can see the CloudFormation stack, the template that was run before. It's the AR model. If we look through the events here, you can see that everything has been complete, everything has finished. And just one tab here is the outputs. So this is a summary of all the resources. And when you run this, if you want to know the URL for your web page, this is where you can find it. So it's all kind of nice here. And to clean up, there is two things you need to do. The first is in the S3 bucket. So I'll switch back over to the S3 bucket and find the bucket. And in the bucket, we have the 3 folders. We have the GLB that was uploaded. And down here, you have the usdz, which was converted. And we also have the HTML files that we're using here. So to clean up, the first thing you do is switch over to the S3 bucket, select your items, and then go under Actions, select Delete, and just confirm the delete. And now that will go through, and everything is now cleaned out of the bucket. I'll flip back to CloudFormation and our stack. Clicking on the stack, we come back in here, and then there's this button up here at the top, says Delete. Click on Delete and just confirm, and then you can see delete has been initiated. And if you flip over to events, you'll see that the delete is going through. And that's much quicker. You know, to provision this takes 5 to 10 minutes. To delete it will take only a couple minutes here. So that is the end of the FAQs. So I'll flip it back to Leo, and he has the next section here.
Thank you, Michael. I'll just take control of the screen again. We hear from customers some common issues that sometimes can come up running through this article, and we'll just go through a few of them here. One of them is that when your models come in, they need to be in meters. This is outlined in the article as well when you read it, and that's because, of course, we want the chair and other objects to show up in correct real-world sizing. So the world needs to pick on a standard for measurement about what 1 unit in the model represents, and the standard is 1 meter. This doesn't mean that your model will come in as meters. If your model comes in using inches or centimeters as units, your model will be the wrong size. It'll either be way too big or way too small. So if that happens from one of your models, go into a open source modeler such as Blender and scale the model to the correct size so that 1 unit in the model represents 1 meter, and then it'll show up to the correct size in AR. And then the second thing that you often run into is this thing called CloudFront caching. So CloudFront is our content distribution network, and it allows customers, your customers around the world, to have a very low latency download of the experience. It does that through caching through our AWS infrastructure and backbone by caching the pages and the data on those pages at edge nodes, or points, what we call points of presence. So in this particular example, the first person who downloads that chair, it takes the chair from the origin, which is your S3 bucket, and caches it near the customer, near the point of presence, so that the next customer who comes in and makes the same request for the same data, CloudFront will serve that content from the cache closer to the customer rather than the point of origin, and your customer gets a lower latency download for that. That's the great part about CloudFront. The downside of that is if you iterate the model, so if you go and re-upload the chair and have a different version of the chair under the same name, CloudFront, when you go to reload the page, serves you the cached version rather than the new origin version. In order to get the new origin version to come up, you have to go into CloudFront and invalidate the cache for those particular objects. And you can do a web search on CloudFront cache invalidations and read how to do that in the documentation. There is a small charge for doing invalidations. Another way to do it is to use new file names. So because the caching is based on the content file names, if we would have called the chair Pergolesi chair v1 and then v2 and then v3, every time we change the file name, it would recache a new version of that content, so you don't have to invalidate the caches. And this is really important if you're iterating your content. What will happen if you don't do this is you say you had the chair at the wrong scale and you re-upload it at the right scale, and then you refresh your page and it still shows it at the old scale. That's because it's serving the cache. So you either have to invalidate the cache or choose a new file name. Something to watch out for as you develop. And that's about all we have to present. So I hope you found this webinar valuable. We are going to go live with a Q&A to take your questions that you may have in the chat window if you're watching live. And we look forward to seeing what you create on your websites as online retailers or otherwise for interactive AR previews of products in your space. Thank you very much for watching.